Coming up on the FRC Open Alliance show, 4481 Team Rembrandts is back. This awesome team from the Netherlands has so many great updates to showcase, including improvements to what they're doing for their climbing mechanism, which you definitely got to check out. We're going to get some live demos as well, too, of them scoring on the reef. So definitely some great things to dive into there. And then we're going to be diving more into their autonomous mode, some of their pathing, what they're looking at doing, maybe some future aspirations as well. So let's check back in with 4481 Team Rembrandts here on the FRC Open Alliance show. Let's welcome back on the FRC Open Alliance show, 4481 Team Rembrandts from the Netherlands. It is always awesome to see this team on, get all the updates. I just watched the week 4 recap video that y'all did, and the amount of updates from the first time we had you on to where you are now is absolutely incredible. I know we got a lot of great demos to showcase today and talk about. So we got 3 new students on. Why don't you introduce yourselves, let us know what you do in your team, and we're going to get right into that coral algae manipulator. That's really cool.
Yeah, so I'm Niels, and I'm from the software department.
I'm Thomas, and I'm also in the software department.
And my name is Suus, and I'm from the hardware department. So I'm going to first talk about the coral algae. It is a subsystem that makes sure that we can remove algae from the reef and score coral at the same time. So what we do is we get the algae out of the reef, and at the same time, we can turn it and we can score the coral. So we don't have to drive back to get something or to leave something. We can just get it from the reef, turn it, and score the coral. This makes sure that we can all do it in one move. It saves us a lot of time, and it is also really productive to just do it in one move. It also makes sure that we can hold 2 game key pieces at the same time. So that's also something that's really productive.
I have a question about that, the intake on there. So when we see that intake, that belt hit the algae, only the bottom part hits first, and then it goes into the top part. Can you talk a little bit more about that?
So we have one turning, and then it just makes sure that it lifts the algae up, and then it goes into the intake. So it grips, the other one turns the other way around. So it just grips the algae from 2 sides, and then it makes sure it's secure on both sides so it doesn't fall out.
So I guess my question specifically is, when you were looking at creating that grabber, why not have like both touch at the same time? Like, why did you end up going the route of just the bottom touching first? Like, what did you see that made that make sense for your team?
The reason why the bottom roller touches it first is because it simply doesn't reach far enough. And we did this because we are afraid that maybe the gripper will get stuck on one of the reefs. And this way we make sure that we can take the algae and it doesn't get stuck. So we started this week with the tuning of the pivot and the elevator. And we did this by running a small autonomous mode that moves the pivot and the elevator up and down slowly and eventually much faster. And we do it this way so we can get accurate PID tuning for it. And to make sure it is as fast as possible while also still being very accurate. So we tuned the pivot this way, and we did it to make it as fast as possible. And we needed to account for the weight of the pivot also with the elevator, and now we do it. We make sure that the pivot is always in the stowed position when the elevator goes up, to make sure that we don't hit the reef. And we do this with the sequence, so we make sure the pivot is in the right place. Then we move the elevator up, and then we move the pivot to the scoring location.
Yeah, so we also had to account for the gripper and the lift and the elevator because we don't want them to collide with each other. So we did that in VantageScope, and we made a sort of simulator, and in that we tested if they would collide with each other.
So in all this testing that your team has been doing for things, you mentioned a couple of things you had to try to help fix. Were there any other major difficulties that your team had while doing your tuning, or maybe anything that like, hey, we found this out, so we did something differently based on that?
There were a lot of like differentialities in our tuning. A lot went wrong in the tuning, but eventually we came to a good constant.
So what were some of the things that maybe went wrong for you?
The motor was kind of gripping on the edges, and the motor was slipping, and that just made it a lot less accurate.
Another thing that we encountered was that we couldn't move our pivot as far as we wanted to intake the coral, and we eventually fixed this by just moving the limit switch, which stopped the pivot when it came too far. And we are also planning on extending our lift a bit further, because now it doesn't reach the height that we actually want.
So one of the things that I've been really excited to see is your climber, because your team has been able to climb really quick, kind of on the move as well too. Can we dive more into how your climber's been all coming along and show more of that?
Yeah. So with the climber, we tested a lot of different climbing systems, and eventually we found out that the climbing system from the FRC is working best for us. So what we do, what you also see on the video, we drive into the cage, it clicks itself on the metal, pulls it into the hole beneath, then it tilts a little and it pulls itself up so that it stays stable into the air, and that it's not tilting anymore. So it just climbs, like it tilts the cage and it climbs itself up, and then makes sure it's stable with center of gravity into the cage.
So it's great to hear that you're using the EveryBot climber. A lot of teams we've talked to are utilizing that. Did you make any modifications to the EveryBot climber other than just the packaging aspect of it?
We haven't, because we just first wanted to test this, how great this was working. But now we have we see some things that we think we need to improve, and we are already planning to improve some things about it to make the climbing easier for the driver.
So what are maybe a couple of things you want to improve on it?
First of all, we wanted to make something to guide the cage into the climber. And this will also act as a safety to our robot, so no coral gets stuck in it. And another thing is that we want to shorten the gripper arms, because in this way we can climb more effectively. And the thing that shoots out and into the hole of the cage, we wanted to modify this, because now it gets stuck in the bumper and we want to make it more efficient.
Yeah, it makes sense. And I mean, already impressive for what we've seen so far. So I can't wait to see how it gets fully modified to fit on your robot, and how quickly your team is going to be able to climb is really cool. I know we have a live demo of your coral cycles. Can we showcase that? We'll put that up on camera. And so can you walk us through a little bit what some of these cycles look like for your team?
We added the LEDs to showcase what level we want to score on, and we made sure to make the lift go up a bit before picking up the coral from the coral station, because this way our gripper would be parallel with the ramp of the coral station. We are able to score all 4 levels, and for the L2 and L3 scoring, the lift doesn't need to go up, but for the L4 scoring, it does. We are still working out a bit on the wheels for our gripper, because as you just saw, sometimes the coral might slip, and just like that, the wheels might slip sometimes, and that's what we are trying to figure out, how to improve that.
Yeah. Are you looking at maybe doing a different type of grip on it, or like what are some of your thoughts in terms of improving it?
Yeah, we're trying all kinds of different wheels to see which wheels have the best grip. And we might also change some things on the grip to see if it helps with the grip.
So why don't we do one or two more cycles? We'll show that off, and then we'll hop back to you all. So one of the other things I want to ask you on that, when we saw the robot trying to intake coral from the station as well too, sometimes it didn't always go in that way. Is that something that you're looking at doing something a little bit different with, or is that just practice, that sort of thing? Can you explain that a bit more?
So what we're going to change on the competition robot is that we're going to make the funnel a little bit bigger so that the chance that it intakes it from the coral station is higher because we have a more space to make sure it goes into the gripper. So that's what we're going to change about that it has a little bit more of wide, that it takes it in a little bit easier. Because now you see that sometimes it goes next to it or it goes a little bit out of place and then it falls off. So that's what we're going to change about it to make sure that it works a little better with the funnel.
Yeah, and one of the things that I'm really excited, and we saw some of that demonstrated here, is some of your pathing as well too, both in autonomous and in what looked like teleop as well too. Can you talk a little bit more about what maybe some of your autonomous paths look like and what you're using for that?
Yes, of course. The autonomous paths were created or thought of by our 3DM department. What they thought would be the most efficient and most scoring path. We decided to name it the Quattro Pounder because it would score 4 corals. It would score the preloaded coral and then drive to the coral station to collect the other 3 corals. This would be the most efficient, we think, and together with great programming, I think this will become a very good autonomous. We still had some time left during these paths, so we might try to make it a 5 coral autonomous. But for now, we are focused on creating the 4 coral autonomous.
One of the things when we have talked to some other teams on what they're looking at doing for their pathing, some teams are really focused on like trying to get one on each reef space, and the other one, like you all, are trying to get multiple levels for it. Have you considered doing kind of the other side where you're like, hey, we're just going to try to do stuff? Or I'm assuming you're going to have multiple different types of autonomous paths available, right?
For now, we are only focusing on this one, and we are only scoring on the L4 because we didn't want to need to remove any of the algae during the autonomous pass. That's the reason why we don't score L3 and L2. Also because it just gives more points to do L4. But for now, we are only focusing on this one, and after it works, we might look at some other paths. But for now, this is the plan we have.
Oh, I didn't quite catch that. That's great. So you're looking at L4 in particular, and that makes a lot of sense to me, right? So that's cool. I look forward to seeing, kind of this in action as you continue to implement and iterate on this as well too. So that's gonna be really neat. Anything else that you all want to talk about or cover on your current progress?
No, I think we covered most of the stuff.
Well, Team Rembrandts, thank you so much for taking the time. I know as we get busier and busier, you all are going to have to pack up and head out for your first event soon. How far in advance are you going to have to ship everything out, or how many days away is that for you?
So we actually don't ship it to the United States, but we take the entire robot in our suitcases. So it flies with us because we have we can take it apart in different subsystems. We divide them over the suitcases of our team members, and then we just we take it with us on the flight we were on, so that we can work on it and fix things till the really last moment.
Yeah, we have something called the plug and play philosophy, in which we can switch out every subsystem of the robot within like 4 screws or something.
Yeah.
And that makes it really easy to take apart the robot, or something breaks, you can replace it really easily, and that's just how we do it.
Yeah, I actually totally forgot you all do that. That's great that you do that as well. By the way, enjoy what might be your last year in California now, because they just, as we're recording this, right, they just announced that California is moving the district. So where are you looking at going maybe in future? Are you looking at way up north in the States and enjoying the snow in Minnesota, or what do you have in mind?
At this moment, we really don't know, but I think that's something we will look at in the future. Right now, we're just focusing on this year, and what comes next year, and we'll see.
That's fair enough on there. Yeah, good luck, Rembrandts. We can't wait to see how you do. And you're competing weeks 1 and week 2 at Pinnacles and Ventura County. So good luck the rest of the way, and we'll see you there.
Thank you.
Thank you.